Okay guys, welcome back again to another BrainFX video. In this one guys, we're going to answer questions from question 12 to question 18 from 2022 tutorial sheet. And this is physics, by the way. Okay, let's begin with our first question, which is question 12. Express the following in terms of prefixes. So we have A, we are told to express 0.00085 liters. Okay, so this one can be written as 85. We can write it as 85. Then, once we write it as 85, okay, so since the question doesn't specify the prefixes in which we should write them, you can choose any prefix that you wish to write them in. So for this one, I will write it to, okay, I want to write it as 850. So if I want to write it as 850, the point to move how many steps? So we can say to move 1, 2, 3, 4, 5, 6. So it will make 6 steps. So it will be times 10 to the power negative 6. And I know 10 to the power negative 6 is related to this part. It's related to micro. So I can write it as 850 microliters. So this one is our answer for question A. Okay, let's do B. So B, we have 5.44 times 10 to the power negative 11. Okay, this one, let's say I want to write it as an O number. So this one, to write it as an O number, it will be 544. The point will be there. So it has moved 2 steps. So since it's moving in our left direction, it will be 10 to the power. This side, we're going to add the steps that it has moved. So it will be 11, 12. It will be 13, by the way. It will be 12, 13. So you are going to have 13 on top. Now, we can check on our list of prefixes under metric system. Yeah, which prefix has this kind of exponent? We don't have anything with 13, but we have something with 12. So let's write it to 12. So we can write it as 54.4 times 10 to the power negative 12. Yeah, this way it can be written as 54.4 negative 12. That's negative 12. We know that that's pico, so it will be picoliters. So this one will be your solution. Okay, let's do C. So on C, if you want to write it in any prefix, we have 73,000,000 meters. So this one, let's say we want to write it in prefix. We can write it as 73. So let's move the point. How many steps? 1, 2, 3, 4, 5, 6. So we've moved the point 6 times. Yeah, is it 6? Let's count it again. 1, 2, 3, 4, 5, 6. Yeah, it's 6. So it's 10 to the power 6. And 10 to the power 6 is related to mega. So it will be mega meters. So that's how we can write it in prefix. Okay. Then our last part, which is 9.450 seconds, we can write it as 9.450. So that way the point has moved to the left 1, 2, 3 steps. So it will be negative 3 there. And we know that 10 to the power negative 3, it's related to milli. So we can write it as 9.450 milliseconds. So that's how you can write these questions in prefixes. Okay, let's jump to 13. So on 13, we are told to identify the number of significant figures in the following. So we need to identify the number of significant figures in the following. And we are given the first one as 9,500 seconds. And we are told to state the number of significant figures. By the way, if you are not familiar with how to state the number of significant figures of a given number, you can watch my video titled Significant Figures. Yeah, so in this one, we have two significant figures. So in this one, we have two significant figures. Why? We have a rule that states if you have trailing zeros, these ones, if you have trailing zeros in a number without a decimal place, they are not what? They are not significant. So they shouldn't be counted. So since this number has no decimal place, or it has no decimal point, we can say it has only two significant figures. So it has only two significant figures. Okay, let's do another question. The next question is 0.00702. So this number, we have a rule that states leading zeros are not significant. So we have a rule that states leading zeros are not significant, and leading zeros are zeros this side, leading zeros before a non-zero integers, they are not significant. So regardless of us having a decimal point there, we have a rule that states leading zeros are not significant. Yeah, so they won't be counted. So we have three significant figures in this one. Three significant figures. Remember, zeros in between non-zero integers, this one is counted as significant. Okay, so that's the answer for this one. Let's do C. C, it's 1.040 times 10 to the power negative 5 kg. So in this one, we know that if you have a number in standard form, we focus on the coefficient. So the coefficient has how many number of significant figures? Oh, it's a decimal number, by the way. So trailing zeros are significant. So this zero will be counted as significant because of the decimal point. So we have 1, 2, 3, 4. We have 4 significant figures in this one. We only focus on the coefficient. Ignore this part. Okay, we have now 7.600 milliliters. In this one, since it's a decimal number, trailing zeros are what? Are significant. So we have 1, 2, 3, 4. So we have 4 significant figures in this particular question. So that's it for question 13. And those are the solutions for each sub part. Okay, now let's do question 14. So question 14 says, express the following. So we have 100 liters per hour, and we're told to express it in centimeter, in cubic meters per. We are told to write them in cubic meters per second. Okay, so cubic, it will be written this way per second. Yeah, we are told to express them, to write it in this way. By the way, units of these kinds has to do with the flow rate. Yeah, the speed at which a particular fluid is flowing. Yeah, so to convert this one, we need to know what a liter is. A liter is just 1 decimeter cubed. Yeah. Okay, now that we know what a liter is, we can now convert it. So we are given 100 decimeter cubed per hour. So per means 1 hour. So this one, we can convert it by changing first decimeter to meters. We know that in 1 decimeter, we have 10. Remember, this it's related to 10 to the power negative 1. So we're going to put our meters there. Now for us to be able to cancel the units, we need to power it to 3. Yeah, so that part and that part will cancel. So we've now converted it into cubic meters. From there now we need to convert the hours into seconds. We know that in 1 hour we have 3,600 seconds. So now the hour and hour will cancel, and our units will be, we can lab this part, including the top part there. So our value will be, our units first will be, remaining units will be meters with a power 3, which is cubic meter per second. Then now it's just a matter of you punching this. So 100 times 10 to the power negative 1 divided by 3600. You're going to get a value of 2.777 times 10 to the power negative 3 as your value. Okay, I've made a mistake. It's 100 times 10 to the power negative 3, then divided by that value. Okay, so it will be 8 there times 10 to the power negative 5. So this one must be your solution for A. Okay, let's jump to B. So on B, let's jump to B. So on B, we are told to convert 1 atmosphere to pascals. Okay, this has to do with pressure. We are told to convert 1 atmosphere to pascals. So you need to know the conventional factor between pascals and ATM. So we know that 1 ATM it's equal to 1013 to 5 pascals. Yeah, so 1 ATM is equal to 1013.25 pascals. So now we can convert it as follows. Okay, since it's one ATM, there's nothing to convert. This is our answer. That's our answer. There's nothing to convert. Okay, so let's do C. Let's convert 100 dyne to newtons. So we know that 100 dyne, we convert it to newtons. 1 dyne, it's the same as 1 gram centimeter per second squared. And a newton, it's the same as 1 kg per meter, 1 kg meter per second squared. Yeah. So now that we know these two, we can easily now convert 100 dyne. So we can say 100 dyne is the same as 100 gram centimeter per second squared. Yeah. Which can be written as per second squared. I can write it at the bottom as second squared. And centimeter there is the same as 1 centimeter multiplied by. So I need to convert the grams into kg and the centimeter into meters. Okay, let's begin by converting centimeters into meters. So we know that 100 centimeters, we have 1 meter. Then let's convert a gram into a kg. So we know that in what makes up a kilogram, it's 1,000 grams. So what makes up a kilogram? So that way that one and that one will cancel. This one and that one will cancel. Seconds won't be affected since there we have seconds and at the bottom we have seconds. Okay, let's punch it in. So we can say when you punch this one in, your calculator, it's 100 divided by 100, then divided by 1,000. You're going to get a value of 1.0 times 10 to the power negative 3. Your units will be kg meter per square second. Yeah. So those ones will be your units. And we know that this one is the same as a newton. So we are saying this is a newton. So that will be a solution. There is a better way of doing this. Rather than you breaking down what a dyne is and what a newton is, you can just write it as, we know that in 100,000 dyne, it's equal to 1 newton. So if you know this conversion, you can use it as well. So from there now, it's just a matter of saying we're given 100 dyne. So we can say a 100,000 dyne at the bottom, it's equal to 1 newton. That part and that part you cancel, so we can just say 100 divided by 100,000, which will give you a value of 0.001 newton. It's the same as our value there. Yeah. So that's how we convert it. Okay, let's jump to question 15. Okay, so question 15 leads, estimate how many people, if they stood on top of each other, would reach the moon. Okay, how many people, if they stood on top of each other, would reach the moon? Okay, so we need to power them one after another. So if this one is standing, the other one is standing on top of the head of the other one, yeah, until we reach the moon. Okay, so in this question, just need to know the distance from the Earth to the moon. So the distance from the Earth to the moon, it's equal to 384,400. Yeah, it's equal to 384,400 kilometers. And we know that the average height of a human being, it's 1.63, yeah, 1.63 meters. 1.63 meters. Okay, we can now find the number of people that are required to reach the moon. Okay, so to reach the moon, we can just convert this one into meters. So let's do it. So to convert that one into meters, you're saying this one has to be converted into meters. We know that 1 kilometer, we have 1,000 meters. Kilometer and kilometer will cancel, and we are going to get a value of times 1,000. So we are going to get a value of that amount, 400, then 000. Yeah. So this will be our value in meters. Then now from there, we're going to divide. You're going to say number of people required to reach the moon. Number of people required to reach the moon will be equal to that particular distance divided by 1.63, the average length of a human being. Okay, we can get rid of these things. Then when you divide it, we are saying 1.63 to be equal to, we are going to get a value of 235,828,220.9. Okay, 0.9 as the number of people. Now we can say 0.9, yeah, people. So we need to convert it to a whole number. So to convert it to a whole number, it will be 21 at the end. So it will be that figure. So those are the number of people required to reach the moon. So we're saying people required to reach the moon. It's quite a big number, yeah. Okay, let's do question 6. This one was quite an awkward question because I don't know whether a person need to memorize the length from the Earth to the moon. Anyway, we've done it. Let's go to 16, question 16. So question 16 leads, if the unit of force is 100 Newton, unit of mass is 10 meters, and the unit of time, it's 100 fortnight. Wait a minute. It's 100 seconds. What is the unit of mass in this system of units? What is the unity of mass in this system of units? Okay, we need to know the relationship between force, mass, and time. Okay, so we're given these ones. This one is related to force. This one is related to mass, and that one is time. So let's see the relationship between these three. We know that the only formula that relates these three dimensions together, it's force is equals to ma. So let's use this one. We know that in this case we are given the force. So let's consider a force as a dimension. So we can write it in this way as a dimension formula. Will be equal to the mass. We are told mass, we know it's represented by capital letter M. And we have acceleration. Acceleration too will be written as meters per time squared, but to be negative squared. Yeah, to be negative squared, that way. Then from there now, we're interested in knowing the dimension of mass, this one. So let's make it the subject of the formula. By the way, I'm using dimensional analysis to arrive at the answer. So we can say if we made this one the subject of the formula, we are going to get force as a dimension. By the way, if you want, you can split, you can break it down. You can write force in its physical quantity dimension. Yeah, so you can say force is a combination of, you can write a Newton as mass, then we have length, and we have time. You can break it down that way. Yeah, but I'll do it this way because it will be more easier. So from there now, we need to divide it by L, that one, and you need to divide it by t to the power negative 2. So since we are dividing it, okay, it will be divided by 2, negative 2, like that. Okay, now from this step, it's just a matter of us now replacing the dimensions that we have. So we are given that a force is that one, so we can put that amount of unit on force. So we can say mass. On force, we are going to put that unit, which is 100 Newton, divided by, on length, we are given is a 10, and on time, we are told it's 100. Okay, we know that a Newton, it's equal to, we know that 1 Newton is equal to kilogram meter per square second. So let's write that there so that we have some consistency in our units. So we can write it this way. Okay, now we can get rid of these things, this side, and we can say mass, the dimensions for mass will be equal to, let's simplify this one. So we are saying we have 100 kilogram meter square seconds divided by, the bottom part will give us, of course it will be meters, it won't be affected. Then 100 seconds, we know that we can give it those non-can units, and we can say 100 to the power negative 2. So it's 100 to the power negative 2. That will give us a 10 to the power negative 4. And the seconds will have the power of negative 2. But if I want, I can put seconds on top, and it can be written as, let me get rid of these ones. So I'm saying mass will be equal to, seconds can go on top because we have a negative 2 there. So we can write it as seconds squared. We can write it as seconds squared. Then from there now we can have our bottom part. We can have that particular units. Okay, this one, it's going on top because we have a negative. So it will be 10 to the power 4. Yeah. Then on the bottom, we're going to have 10 meters. Now just punch that into your calculator. You're saying 100 times 10 to the power 4 divided by a 10. We are going to get 100,000. Now let's see how the units are cancelling. That part and that part can cancel. This one and that can cancel. This one and that can cancel. So I'm going to remain with kg as your unit for mass. So that one will be the unit of mass in this particular type of system. Okay, so that's it for question 16. Okay, so question 17, we are told that a 4 line has those number of yards, a mile has that number of yards, or that number of meters. A fortnight, we are told it has 14 days. Then we are told that there's a Zambian athlete who went to Switzerland, and when he represented Zambia in this number of meters, his average speed was this amount per second. They are taught to express the speed in kilometers per minute. Okay, so we have 8.5 meters per second, and we are taught to express it as kilometers per minute. Let's do it. So we're given 8.5 meters per second, so that's 1 second. Multiplied by, let's convert seconds into minutes. So to convert seconds into minutes, we can say per every minute, we have 60 seconds. That way, seconds and seconds will cancel. We're going to remain with minutes. Now let's convert meters into kilometers. We know that per every 1,000 meters, it's a kilometer. So that part and that part will go, and our units will be kilometers per minute. Now it's just a matter of punching that into your calculator. 8.5 times 60 divided by 1,000. You're going to get a value of 0.51 kilometers as your value. Okay, let's jump to B. So B, we are told to convert the same unit. This time we're going to convert it to miles per hour. So miles per hour. Wow. We must know what a mile is. We know that a mile is equal to 1,609 meters. So we are saying 1 mile, it's equal to 1,000 or 1,609 meters. Yeah. So now we can do the conversion. 8 meters per second. We can convert seconds into minutes by saying 60 seconds. It's equal to 1 minute. Then we can convert meters to miles by saying 1,609 meters is equal to a mile. So that part and that part to cancel, that and that to cancel. Your value will be 8.5 times 60 divided by 1,609. Okay, we are going to get a value of 0.3. Remember, we're converting it into miles per, we are told to convert it into miles per hour, not miles per minute. It's per hour. So we need to include times. So from minutes now to hours. So it will be 60 minutes per every 1 hour. Yeah. So now the value will be different. When you punch it into your calculator, you're going to get a value of, we're saying 8.5 times 60 times 60. Then we divide it by 1609. You're going to get 19.02 miles per hour. Yeah, that must be your answer. Okay, let's do the last part. So the last part, we are told to convert it into a furlong per fortnight. Yeah. So a furlong per fortnight. We are told what a furlong is. It's 220 yards. Okay, this one will be a little bit tedious, but anyway, we can do it. So it's 8.5 meters per second. Let's begin by changing time. So we can change time to fortnight as follows. We can say for time, we can begin by saying we have 3,600 seconds in 1 hour. You see that? Oh, by the way, a fortnight, it's equal to what? We are told what a fortnight is equal to 14 days. And we know that 1 day, it's equal to a day. It's equal to 24 hours. So now we can say 24 hours, it's equal to a day. And we know that 14 days, it's equal to 1 fortnight. So units will cancel this way, and we're going to have fortnight as our final units. Now it's just a matter of converting meters into a furlong. So to convert them into a furlong, we know that we need first to convert meters into yards. So we can do it this way. We know that we have meters. We know that 1609 meters, it's equal to a mile, multiplied by, this time we're going to have miles at the bottom. We know that 1 mile, it's equal to 1760 yards. Multiplied by, we know that we have 220 yards in 1 furlong. So that way, this unit, that unit to cancel that one, will cancel that, meters will cancel with the meters. So we are going to get our unit of interest. So we're going to get the value now. It's just a matter of you now punching that into your calculator. So when you punch it into your calculator, you're going to get a 51,120 furlong per fortnight. Okay, so that's how you go about this question, and that's how you do your conversions. Okay, we are done for question 17. Let's jump to question 18. Okay, let's handle the last part. Question 18. So question 18 says a unit of area often used in measuring land areas is the hectare, defined as 10 to the power 4 meters squared. A new open pit mine, copper mine in Northwestern Province plans to excavate 75 hectares of land down to a depth of 26 meters each year. So each year they will be going that one. So we are saying per year. What volume of earth in cubic kilometers? So we are saying in cubic kilometers should be removed during this time. Okay, so for how many years? The amount of volume per year, we are given as that amount. What is the volume of earth that one should be removed during this time? For how long? We are told the unit of area is defined as that one, and the open pit in this one plans to be excavated this amount. Okay, in this time. Okay, we're not given the time, but we're given the amount of hectares to be excavated. Remember, hectares is related to area. So this one, it's area. This part, it's volume. Let me write it in a better handwriting. And this part, it's time. And we're interested in finding the what? What is the volume? So you're interested in finding the volume of earth that will be excavated from this particular area. Okay, so if you have a question of this kind, you can consider, let's see, are we given the depth? Oh, by the way, this is not the volume, it's the depth, so it has to do with the length. Okay, now here's the relationship between area and volume. We know that volume is equals to L times H times B. Well, area can be calculated as L times H, which means volume can be equal to area times B. Or we can say B there so that we get the H there, yeah, as our depth. Okay, so are we given the area? We're given the area as this one. Are we given the depth? We're given the depth of that amount. Then we're interested in finding the volume. So we don't need time. Time won't be needed. Okay, let's do it. So now that we know the formula, we can write it this side. So we are saying volume is equals to area times the depth, the height of the pit. Okay, so we can begin by calculating the area in meters, in square meters. So we know that we are given 75 hectares of land, and we know that a hectare is equal to 10 to the power 4 square meters. So now we can find our area in square meters as 75 times 10 to the power 4. That will give us a 75,000 meters squared. Wow. So now from there now we can find the volume. So a saying volume will be equal to that particular area of land times the depth. So the depth is 26 meters. Yeah. So now let's punch that one. So when you punch this one, you're going to get the volume of earth as follows. So the volume of earth will be equal to this value, which is the area, times 26. We're going to get a volume of 500,000. Yeah. Meters per this time, since meter squared will be multiplied by m, we're going to get our unit of volume that side. Okay, so this must be your answer for this particular question. Okay guys, that's it for this video. In my next video, I'm going to answer the last 6 questions. That is question 19 to question 24. Yeah, so from question 19 to question 24.